second was 4/8. So I don't know if you guys want to write that down, but 4/7 was the notes section that did quadratic formula. I'm going to start with the word problem because I think that's trickier, and then we're going to move on and go with just kind of more straightforward solve equations with the quadratic formula on the back. Now, you guys are probably going to want a calculator for sure for this question because we're going to round to the nearest hundredth. So if anybody needs to borrow one, feel free to run back and grab one off my desk. All right, now, this says, this is all set up for you, but it says the path of a firework sitting on a table 2 feet off the ground. So not being launched from the ground like this is taller than 2 feet, but just sitting on a table. It has an initial upward velocity of 88 feet per second. Okay, the 2 right here is your initial height because you're on the table, and the 88 is your velocity. That's right there. The -16 is the force of gravity. So the equation for the model of this fireworks path is already kind of set up for us. And you don't have to do this, but just to the side here, let me sketch like a tiny picture. So I'm going to launch this firework up in the air. It comes off of a table that's 2 feet off the ground, so it doesn't start at the origin, but it would go up and then it would eventually come back down to the ground. But it does not start on the ground. So that's just like that little blip there. That'll make more sense in a second when we answer part of this question. Now, somewhere on the way, I don't know where, it says, when is it going to reach a height of 116 feet? So I'm going to go through and substitute in the height, which is the 116 for the h in that formula. All right, so it would just be 116 equals -16t squared plus 88t plus 2. If I have to solve this, I'm trying to figure out what these times are. The best way to do this, I would recommend to you, is the quadratic formula. The thing is, though, you have to set it equal to 0 before you identify your a, b, and c values. So I'm going to subtract the 116 real quick from both sides, and then we would identify our lovely a, b, and c values. So we get 0, -16t squared plus 88t. If I take 2 and I subtract 116, you're going to get -114. And I know some of these numbers are kind of big, but we're literally just going to type this into the calculator. Okay, just to remind you guys so you have it on your paper here, I'm going to write the quadratic formula. So if it's set equal to 0, you can solve it by plugging in the a, b, and c values to the quadratic formula and simplifying best we can on our calculator. That quadratic formula, -b plus or minus square root, all under the square root, you have b squared minus 4ac, and then everybody over 2a. So we're just going to substitute those values based on the equation. A is whatever is in front of the squared term. So a is going to be -16, b is going to be 88, and c is going to be -114. So I'm just subbing these in. So the first piece is the opposite of b. So negative b there would be -88 plus or minus square root 88 squared, 4 times your a value, which is -16 for this problem, times your c value, which is -114. Everybody over 2a, so 2 times -16. Now, this is totally up to you, but I like to kind of simplify just a little bit before I actually try to solve the problem. So what I do is I go ahead and take whatever's under the square root, but not the square root. Like, don't put the square root in here. I'm going to do 88 squared minus 4 times -16. Oops, I can't hit my parenthesis button, times -114. Fail. There we go. You can just type it right into the calculator. So we'd have -88 plus or minus square root 448. And I'm not asking you to break down that radical. If you look back to the directions, it'll say round to the nearest hundredth. We're just going to type this into the calculator here in a second. And then the bottom of the fraction, 2 times -16, is -32. Okay, so If it says round to the nearest hundredth, that just means I actually am going to use the calculator to take that square root. So we don't want to write any negative answers because you can't have a negative time. You can't have an imaginary time either. So if I had a negative under the square root, it basically would mean that that height is not possible. But anywho, I'm just literally typing negative 88. Now you have that plus or minus symbol. You can only do one at a time. So I'm just going to do plus and then take your square root and type in the 448. Sorry, there's a little glare on that. Now, what I would tell you right there, just go ahead and hit enter or equals. And then, after you do that, then divide it by the negative 32. All right, so I'm going to round this to 2 decimal places, 2.09 seconds. That's what I got if I did negative 88 plus. Then I'm just going to repeat that real quick and do negative 88 minus that same square root, 448. Hit equals or enter, and then divide it by the negative 32. So this must, I know I did kind of a rough sketch of the graph, it must hit that height on the way up and then on the way back down after gravity pulls it back down to the ground. So my other time, 3.41 seconds. So there's 2 different times that that lovely firework would hit the height of 116 feet. Is anybody having a question? Okay, this is literally almost the same problem. It says basically at what time or times does the firework hit the ground? What's your height if you're on the ground? 0, right? All right, so this will actually be very similar, but the C value will be different. So I'm going to do 0 equals negative 16t squared plus 88t plus 2. If we can solve this equation, that'll give us when the firework is going to come back down to the ground. Where it would be on the graph would be right here, because you don't start on the ground for the original problem. It starts on a table that's 2 feet tall. So I launch it up, so there should only be one time where it comes back down to the ground, and that would be visually that little point right there on the graph. We're trying to find the t value or x value if you're thinking about xy axis. Now, the only difference here is the C value. Everything else will be the same. The A value is negative 16. The B value is also 88 like it was in the last question, but the C value is different here. It's just going to be 2. I didn't have to subtract anything because it was already set equal to 0, so we can just identify our A, B, and C values from there. Okie dokie. Now, opposite of B is negative 88. I'm just using the same quadratic formula right here. Opposite of B, plus or minus square root. B squared would be 88 squared. 4 times my A value is negative 16 again, but my C value is different. So this quadratic formula will almost look identical. The only thing that will be different is where I put the 2. That's literally the only thing. The bottom is the same. It's 2 times negative 16. All right, now, again, I like to figure out what that number should be under the square root. It's actually the discriminant, your B squared minus 4 times A, which is negative 16, times C, which is 2. And this is a humongous number. I got 7,872. The bottom of the fraction is just like the last one we did because the A value is the same. So 2 times negative 16 is negative 32. Okay, so I'm going to do negative 88 plus or minus is representing 2 answers at once. We just can only do one at a time on the calculator. So do negative 88 plus, do your square root, 7872, hit equals, and then divide that by negative 32. Okay, I'm going to write this down. I got negative 0.0, let's say 2 seconds. If you guys look back at my graph, you never started on the ground. You started 2 feet in the air. So if I actually continued this parabola, it would be back on that side there. You cannot have a negative time though. So I would not write that as the answer. If you get a negative time, do not use that. So that would be kind of on the other side of that parabola since it's attached to a situation. That equation would intersect the x-axis back at 0.02, but it's not going to work for the actual situation in the problem. So we're going to see if my other answer is negative. So I'm going to do negative 88, I did plus, so now I'm going to do negative 88 minus that square root, 7872, hit equals, hit enter, whatever you want to call the button, then divide by negative 32. This is 5.52 seconds. That's positive, so that'll tell you how long the firework will be in the air before it comes back down to the ground. Do not use a negative time. So this previous question, we actually had two answers. It hits it on the way up and it hits it on the way down. The second question, when does it hit the ground, that just has one answer because we can't have a negative time. Is anybody having a question? Okay. Now, discriminates. This is what we did right when we came back from spring break. So I have the discriminant. It's right here in the directions. It's b squared minus 4ac. If you know that number, that can tell you the number and type of solution. So I'm going to write down the three options across the top here real quick so you have it. If that number, b squared minus 4ac, is a positive number, that means your quadratic has two real solutions. If you do b squared minus 4ac and you get a negative number, the discriminant's what goes under the square root. So if I get a negative number, I'd be taking the square root of a negative. That's going to make us use the I. So if you get a negative number there, you're going to have two imaginary solutions. And then the last option, this is the one that's kind of weird. If you get 0, that is going to be 0 under a square root, which is 0. And you're going to have that plus and minus symbol in your quadratic formula, but if you add 0 or subtract 0, it's the same thing. So it's no I involved, but this would just have one real solution. And in that case, if we could look at the graph of whatever parabola we were looking at, the vertex would be what would touch the x-axis. Okay, so we're just going to practice this for these lovely examples down here. So make sure it's set equal to 0, which all of these are, so we don't have to worry about that. And then we're going to call out our a, b, and c values. A, whatever's in front of x squared, so this guy's 6. B is whatever's in front of the plane x, so it's, and if it's got a subtraction sign, look at that like it's a negative number. So b would be -2. And then c is going to be 5. So we're just plugging this in, b squared minus 4ac. So I'm going to do -2. If you're squaring a negative number, make sure when you type it into the calculator that you are using the lovely parentheses and you are putting the squared on the outside. But you can just type this in, just type it right in. So I get -2, we're going to square that, squared on the outside. Just type in exactly how I wrote it. 4 times a, which is 6, times c, which is 5. All right, now I got -116. So if you look up at your options up there, I got a negative number. So a negative number means I have two imaginary solutions. We're not actually solving it. Like if we full on went through and solved this, we could keep going, but we know we have two imaginary solutions. We're not actually finding them for these questions. We're just saying how many and what type. If we look at the second problem, A is -4, B is 20, and C is -25. So I'm just plugging it into that b squared minus 4ac. So we're going to do 20 squared 4 times, whoops, sorry, -4 times -25. Alright, so just grab your calculator. 20, we're going to square it. 4 times -4 times -25. Alright, and I actually got 0. Alright, so that falls into that last category I wrote across the top. If you get a 0 as your discriminant, you're going to have one real solution. And then the last one, I think I did one of each here. A value is 4, the B value is also 4, and the C value is -3 for that problem. So B squared, we're going to have 4 squared, minus 4 part of the formula, and then 4 plugged in for A. Sorry, there's a bunch of 4's in this. And then times -3. And I'm just grabbing the calculator. I'm not asking you to do any of this by hand. So 4 squared minus, whoops, 4 times 4 times, don't forget the negative on the 3. This is a discriminant with a value of 64. So it doesn't matter what the number is. It matters, is it positive, is it negative, or is it 0? 64 is a positive number. So that's going to fall into that first category I wrote down up there, that I'll have two real solutions. Is anybody having a question? Okay. Now, the rest of these are just quadratic equations, and it says you can pick how you want to solve it. So we've got several options. We could do square roots, we could complete the square, we could do quadratic formula. It's totally up to you. I would say maybe a couple of these, there might be a method that might be a little faster than some of the others, but it is truly up to you. Anybody have any idea what they might do with that first equation? I've got 4 and then in parentheses x minus 2 squared equals 64. Like if I put that in front of you, what would you do to solve that equation?
No.
It looks like complete the square, but we don't have to. It's almost already set up for us. Like, just tell me what would you do first? Like, if you had looked at that problem.
Distribute. No.
You want to?
I mean, I know it's extra steps, but this isn't how I do it.
Maybe get. How could I get rid of the 4 without distributing it?
You subtract it.
What I'm doing 4 times the parentheses, right?
Yeah.
So if I'm doing 4 times that, how could I cancel the 4 out? Divide it. There you go. Perfect. Okay. Now, I'm telling you, please, please, please. What he said is totally valid. We could like square that, do like a foil or box, and we could distribute. Please, please, please don't. I'm trying to save you time. Do not distribute. Just divide. Just divide. Then you can just get rid of that 4, and you don't have to mess around with it. I'm totally just trying to save you time here. So this would be x minus 2 squared, and then 64 divided by 4 is 16. Okay, I don't want to FOIL because I don't want to create extra work for myself. I'm trying to do this as efficiently as possible. So does anybody know what my next step would be if I don't want to FOIL? What'd you say? We can't add the 2 yet. We will in a second, but I got parentheses squared. How can I get rid of the parentheses squared? Yes, yes. Your square root. Square root. There you go. And then we'll add the 2 here in a second. Okay, so we're just doing x minus 2. Now, this is super nice for us because 16 is a perfect square, right? If I take the square root of 16, that's 4. You just have to be really careful. Don't forget, when you introduce a square root, like we just did here, you got to put that plus and minus symbol in front of it because there's actually 2 answers. It could be 4 or it could be -4. So that little shorthand way of writing it is to just put plus and minus. Now, I got to do one more step, and now we're going to add the 2. After we got rid of the parentheses, then you can add that to the other side. Now, this question we can take a little bit further. So I have 2, and just scooch that plus or minus over, plus or minus 4. Okay, now, I see no radical. I see no I in this. So that means we can actually combine some like terms here and add or subtract. So remember, this symbol is just a shorthand way of writing 2 different answers. So I want to actually do 2 plus 4, because I can do 2 plus 4, right? It's just 6. And I can actually do 2 minus 4, it's just going to give me -2. So if you can actually simplify it, if you don't see an I and you don't see a radical, then you can take it a step further and actually get the 2 separate answers. Is anybody having a question? Okay. That's square roots. Because I just took a square root. That's square roots. Yeah. Just square roots. If you wanted to do quadratic formula or completing the square on that one, we would have to like FOIL and then distribute the 4 to put it in standard form. Completing the square would be really hard on that one because you'd have a number in front of your x squared term. So quadratic formula if you wanted to do that, but I swear if this would take you like the amount of time it took us. If I did the quadratic formula on that, it would probably take me 10 minutes to do that problem. So if you see parentheses, just get the parentheses alone and then take the square root. So that's square roots. Okay, now honestly, totally up to you guys. Do you want to do, I can't do square roots here. I don't see a parenthesis, and I see an x squared, and I see a separate term with an x. So we can't put those together. So if that's the case, your options are completing the square and quadratic formula. Does anybody have, I tell you what, here's what I would recommend on this one. You can do either one. if you do quadratic formula, you have to set it equal to 0, so I'd have to move the 41 to the other side. If you want to do completing the squared, this would be great because the b value is even and I don't have a number in front of the x squared. So I would actually recommend on this one completing the square. To do that, I'm just going to add a little space to actually complete the square. And I'm going to add that same little blank on the other side because I'm going to try to complete my square on the left side, and if I add something to one side, we have to add it to the other side as well. All right, now, I don't know if you guys are going to remember this because we didn't, I think we did this yesterday, but just in case. If you want to complete the square, it's the b value divided by 2 squared. So for this particular question, it would be 18 divided by 2 squared, which is 9 squared, which would give us 81. All right, so I'm going to add it to that left side. And that's going to give me a perfect square trinomial where the two factors are the same. And then on the right side, we'll just add the numbers together. Okay, now here's the deal. Whatever you square, like we did 9 squared there, that should be the factor that goes with the x. So multiply to get 81, add to get 18 is going to be 9 and 9, or x plus 9 squared. The other side, I just have negative 41 plus 81, which is 40. Okay, now this literally then turns into the problem we just did because I just got something with parentheses squared, and we can just go ahead and cancel it right on out by taking a square root. The one thing that's a little bit tricky about this problem that I didn't have on the last problem. So on the last problem, like I took the square root of 16, and that was a nice number. 40 is not a perfect square, so we're just going to have to do a little work to break that down. All right, so I get x plus 9 plus or minus the square root of 40. Okay, I'm going to just draw a little box to the side here. So we got to break down 40 under a square root. Tell me two numbers that'll multiply to get you 40. 20 and 2. All right. Two numbers that would multiply to get me 20. 10 and 2. Okay, now, broke the 40, broke the 20. I have a pair of 2's right here. Now, you could keep going with this factor tree, and I'm just going to write this with my little yellow marker real quick. Like, 10 can be broken down to 5 and 2, right? But that's not going to give me another pair. So if it doesn't give you another pair, I'm just going to put that back together, and the 10 is going to stay under the square root. So square root of 40 is 2 times the square root of 10. The 10 does not have a partner. It does break down, but it doesn't give you another pair of partners, so the 10 would stay under the square root. So I'm just going to rewrite this real quick. X plus 9 plus or minus 2 roots of 10. Now, I see, right now, I see a radical, right? I see that 2 radical 10. I have to do one more step, but you won't do like what we did on this last question where we can write 2 separate answers. We're going to just keep them together with the plus and minus symbol. I'm going to move this 9 real quick. It's positive, so I'm going to subtract it. But I can't actually add that to the 2 radical 10. They're not like terms. This is 2 separate answers, but it's just a little shorthand way of writing it with that plus and minus symbol. It's not like the last question because I can actually add like 2 and 4, or I can actually subtract 2 and 4. I can't actually add or subtract on like terms. So that should be my answer. I know it looks kind of complicated. Does anybody have any questions? Now, for sure, 23. Okay, the second I see a number in front of the x squared, completing the square is out. Square roots are out here too because we have an x squared and an x. I would recommend quadratic formula on this question because that a value is not 1. If that a value is not 1, do not complete the square. It's going to be a pain in the butt. All right, so I'm going to get my a, b, and c values. It's already set equal to 0. So a is whatever's in front of x squared, so it's 2. Now, the middle term, you just have minus x, so it's not written there, but there would be like a little negative 1 in front of the x, and then there is a negative 1 written for the c value. Once you got that, we're just going to go quadratic formula. And I don't know if I'm going to write it on my paper. You guys don't need to write it again if you don't want to, but this is what I'm going to plug it into, so I have that written there. Negative b plus or minus square root b squared minus 4ac all over 2a. So this is a little weird. So the first part is negative b or the opposite of b. B is already negative, so if I do negative, negative, it's actually going to look like a positive 1 because it's the opposite of b. So it'd be 1 plus or minus square root 1 squared minus 4 times a value is 2 times my c value, which is negative 1. And everybody over 2a, so 2 times 2. Alright, so I got 1 plus or minus. Let's figure out what's under the square root. I'm just grabbing my calculator to do that. So negative 1 squared minus 4 times 2 times negative 1. I'm not including the square root. I'm just doing what's underneath here. And I ended up with 9. The bottom of that fraction, 2 times 2, would give you 4. What is the square root of 9? 3. That's a nice number. Okay, now here's the deal. If I take that square root of 9, you don't see any radical and you don't see any I, right? So we can actually simplify this. So I'm just going to break this apart real quick. If I do 1 plus 3 over 4, we can actually do that. 1 plus 3 is 4 over 4. That becomes 1. And then I can actually do the other one, 1 minus 3 over 4. That top part of that would be negative 2 over 4, and then we can reduce that negative 1/2. So that in that case, I got rid of the radicals. We don't have any i's or anything, so you can actually simplify that to get 2 separate answers instead of leaving the plus and minus. Is anybody having a question? Okay. Let's try one more here. And again, if you want to use quadratic formula, you could use that. Like I would add the 30 to the other side. I might recommend completing the square on this only because the b value is negative 8 and that's even. So I might just do completing the square. So I'm going to do x squared minus 8x. I'm going to leave a little blank. And then equals negative 30 plus I'm going to leave a little blank to complete the square. To complete the square, you just got to grab your b value, which is negative 8. Divide that by 2 and square it. Now that's negative 4 squared, which anytime you square something should become positive, whether it's a negative number or a positive number. So negative 4 times negative 4 is positive 16. If you did it correctly, I swear to you, whatever you squared, which was negative 4 here, that should be your factor. So multiply to get 16, add to get negative 8. I squared negative 4, so it would be x minus 4. Negative 4 times negative 4 is 16, and negative 4 plus negative 4 is negative 8. And then on the other side, we're just going to add these. So negative 30 plus 16 is negative 14. All right. Then once I'm there, you're just square root. If you have a lovely negative under the square root, we're still going to put a plus and minus. But let's just say, okay, square root of a negative number, we're going to pull an I out in front and leave that 14 underneath. That gets rid of the negative. Does 14 break down under a square root? I'm going to write it to the side just real quick here. If you did like 14, you could do a little bit of a factor tree like just 7 and 2, but you're not going to get any pairs out of it, so that actually doesn't break down under a square root. I do have to do one more thing before I write my final answer. I'm going to move this 4 away from the x by adding it to the other side. Now, on the other side, I got an I, which is a problem, and I got a radical, which is also a problem. I cannot put 4 with an imaginary or an irrational number, so you're just going to leave your answer. Just put the 4 right after the equal sign and just kind of shove the plus or minus I radical 14 over. That is your set of 2 answers right there. Can't go any farther because I can't add 4 to an I. I can't add 4 to a radical. Is anybody having a question? Okay, we're going to do just these last 2 at the top real quick. And then we'll be done. And if you guys want to do the multiple choice for extra practice, I'll give you the answers for those, but those are really just if you want to practice some more. How would you go about solving number 25? I've got 5x squared plus 405 equals 0. Would you complete the square, quadratic formula? Could I just get a x squared by itself?
There's no b in that formula that makes but complete the square, right? Which one's line?
Square roots. Square roots.
Oh, square roots.
Yeah. Okay, yeah, you got no bx term. Okay, if you want to use quadratic formula, you can. You'd plug in 0 for b, but don't do extra work for yourself. You can get this x squared alone. All right, right? If I can do that, there's no x, there's just an x squared. You can just get it alone. So just 2 steps. I'm going to move the 405 by subtracting it. You got 5. Don't take a square root yet. You got a 5x squared is negative 405. We're just going to divide by 5, because I can get this x totally by itself. Right? So then I've got x squared equals, what is that? Negative 81. Negative, no big deal. We'll just use an I. All right, square root to get rid of the squared. And we introduced the square root into the lovely problem there. So we got to put our plus and minus symbol, because there's 2 answers to this. What would those 2 answers be? Like, what would you write next to the plus minus? 9. 9i. That's because you got the negative. That's a perfect square in imaginary land. You just got to put the I next to it because of the negative. That's it. There's your 2 answers. Positive 9i, negative 9i. All right, and I got one more. Last one, promise. All right, I would, if you got a number in front of the x squared, I would definitely just go ahead and use quadratic formula on this. So your a value is 6, your b value is 2, and your c value is 3. Sorry, I'm at the top of the page a little bit. All right, opposite of b would be negative 2 plus or minus square root. B squared is 2 squared. 4 times the a value is 6 times the c value is 3. All over 2a, which would be 2 times 6. Okay, now, I'm not going to lie to you, this one's a little bit hard to break down, but when you go ahead and do what's under the square root, so I'm doing 2 squared, 4 times 6 times 3. I'm not including the square root, I'm just doing what's under the square root. This is negative 68. The bottom of that fraction would be 12. Okay, now, 68 is not a perfect square, so let me come over here to the side just so we can have a little space to break this down. So if I have negative 68 under a square root, I'm going to take an I out in front to get rid of the negative, and we're going to try and break down 68. Can anybody, this is kind of tricky. The tree's not really big here. Does anybody know 2 numbers that would multiply to give you 68? 34 and 2. Yeah, and then you stop. Yeah, 17 is a prime number. Okay, so you do have a pair of 2s. The 17 would stay underneath. Okay, now, remember, there's an I with this out in front. So when I write this, I'm going to write negative 2 plus or minus 2i radical 17 over 12. Now, I'm not trying to be mean or anything, but this actually can further be simplified in this particular question. Okay, do not touch the radical. Don't even look at that 17. It shouldn't probably be a problem here. If all 3 of these numbers, I've got negative 2, I've got 2i, and I've got 12. If they're all divisible by something, those are all divisible by 2, you can actually reduce that. So this should, I'm just going to divide each one of those 3 numbers I highlighted by 2. Negative 2 divided by 2 would be negative 1. Plus or minus, this is a little weird, but if I do 2i divided by 2, that would just be 1i, or probably not going to see the 1 written in front of it, just an I. Keep the radical 17, that should not change. And then 12 divided by 2 is 6. And I know that's really rough looking, but you can't simplify that any further. That's simplest radical form. Can't add real numbers to the i's and can't add them with radicals if they don't have like radicals. So 2 answers there with the plus or minus symbol, and that's the last one. Is anybody having a question? Okay, these are just optional at the bottom if you want some extra practice. I would use quadratic formula on all 3 of these, but you don't have to. I just want to tell you what the answers are real quick, because if you want to do them, I want you to know what they are. All right, so I'm just going to write these real quick. If you want to do these for extra practice, you should get A for 27. You should get D for 28, and you should get C for 29. So if you do want to do some extra practice, those last 3 questions, let me move this out. You can, if you're feeling comfortable with this, you're like, okay, I got it, I know the quadratic formula, then you're good to go. But if you want to practice those, then you have those answers so you can look at them if you want to. So those last 3 questions, optional if you want to do them. I won't take points off if you don't do them. because I am going to collect this paper from you tomorrow. Is anybody having a question? Okay, we don't have a ton of time left. All we're going to do, obviously there's no homework, but I would go back and review this a little bit. If you want to write any additional notes for yourself, like in the margins or anything to use on the test tomorrow, you are welcome to do that. I need to collect your notes and I need to collect your study guide here after you take the test, because you can use that on the test, but I'm going to collect those from you tomorrow and give you credit for doing that stuff. So if anybody wants help with anything,